Hi, and welcome to IB Twitter. We want to continue with our revision on COS 1512. And in this video, we are going to be looking at basics on classes. And for this module, this is the core of the course. I mean, this is one area that you really have to master, because everything that you do, I think, hovers around classes. It's like 50% of the course. So you really have to understand classes and know how to define, implement, and use classes, because it's really crucial for this course. You cannot pass this module without understanding classes, really. So yeah, you have to spend a lot of time here practicing, trying things out until you really grasp the gist of it. So basically, a class is a complex type, because I know you, coming from COS 1511, you would have looked at functions. And a class is now a more complex object, which is now a grouping of those functions, which means a class is an object that needs to carry out certain functionality. It's like when you say, I've got a calculator, you can use it to do a bunch of things. That's an object. So we follow what is referred to as object-oriented programming, which is programming oriented towards objects. So the way you refer to real-world objects, that is how your code also behaves. And when we then talk about an object, now we are referring to a class, which means if we are creating an application that handles students, a student then becomes an object, which is a class. So, and an object then has, attributes like the data that defines it. It has functions, which is what it does. So a class is basically made up of, the data that it carries and the functions which it also does. So that's a class. It's a complex type. It's an object which allows you which can hold data and carry out a number of functions, right? So talking about classes, you are going to realize that most of the confusion with classes comes in terms of understanding like the code, like where do I do what? And when I say this, it's because whenever you're doing classes, you're going to follow three basic steps. You're going to define your class, you're going to implement your class, and you're going to use your class. And in each of these three stages, there are principles that govern how each of these steps are done. There are rules around what can or cannot be done. So it's very important for you to understand where you are each time you're dealing with a class. Are you defining it? Are you implementing it? Or are you using it? It's very, very crucial, because at each phase or at each point, there are rules that govern what can or what cannot be done. And it's easier to understand, like if okay, under a class definition, this is what I need to do, this is what can be done, this is what cannot be done. When implementing a class, this is what can or cannot be done. And when using a class, this is what can or cannot be done. It's very crucial, because I've seen that most confusion comes when people don't really know at what stage they are. So you see people trying to do, writing code that they would use when implementing a class when they are trying to use it, or sometimes they would write code that they should write when defining a class, when trying to use it, or sometimes the implementation involves someone trying to use a class. There's like a whole lot of confusion that happens because people are not very clear which stage am I. So the class definition phase is where you create a class. This is where you say, I want a class called student, or I want a class called month, whatever it is that you're dealing with. And then you define its structure, like what it looks like. Implementation simply involves providing the functionality for each function. You are simply implementing all your functions. That is the only thing that happens at stage number 2. And then stage number 3, this is where you begin to use your class as an instance, or you start making objects of your class, or you start making instances or instantiating objects of your class. And the terminology sometimes can be confusing, but in other words, if you think of it in simple terms, class usage is what you do with integers, int x. You have instantiated an object of type integer called x, or you have created an object of type integer called x. So there are so many different ways of saying it, but in actual terms, it's as simple as this, because an integer is a class, which means you have been using classes, you've been instantiating them, only that you were not really thinking about it. All right. So we're going to talk more about defining a class, understanding the basic principles around defining a class, and then we'll talk about implementation, and then we are going to talk about class usage, and then In the second section on the next video, we're going to talk about overloading operators, which is also one of the most common things you do with classes. So when it comes to class definition or defining a class is made up of two main sections or three sections, but right now let's just go with two. The first section here is where you put your member functions. And here you say, these are the, this is what my class needs to do. And what you put here are what I refer to as member variables. Remember, we said a class is an object that can hold data and then act on that data by providing functionality. So in other words, this is also sometimes referred to as the state of the class, because this is where you give it values. For example, in this case, we are dealing with a class called day of month, day of year, which means it's an object which represents a day of year. And this object is made up of two attributes, which is the month and the day. So each day is then defined as the day and the month. So you can say it's the 6th of the 4th month, or it's the 20th of the 10th month, excuse me, and so on. So these are your member variables. And you'd notice that always you make your member variables private, right? It's not like you cannot make them public. And these here are our access modifiers. They define the accessibility of our objects. So in terms of access modifiers, we've got three types. We've got public, we've got private, and we won't talk about it now, but we have protected, which we will talk about when we start talking about inheritance, right? So at the end of classes, at the end of this video, we're going to talk about what I refer to as ADTs, and we'll come back and revisit the idea behind these access modifiers. But whenever you're defining a class, the idea behind this is that when you think of a class as an object, and let's say, for example, you've got a smartphone, right? You're going to realize that, you have access to certain things on your phone. Here's my phone, right? Let's say it's a full screen, whatever. And there's a notch here and a camera here, right? There's a smartphone. And some buttons here, right? For instance. So you're going to realize that for this phone to work, there are certain things that it needs for it to be a working device. For example, we can talk about the motherboard, which controls all the electronics inside your phone. We can talk, there is also a charging system in there, which is maybe part of the motherboard. There are some, GPS components that are in there. There's there's a lot of components. There's also your battery that is also in there. All these items are internal to the phone, right? When you're buying a phone, you may really want to know the specs. But when you're using it, you don't really care about, what's happening in the electronics, the electrons and the charging, whatever is happening inside. You don't really care about that, because the phone has an internal system which allows it to carry out certain functions. At the end of the day, all you want to be able to do is, make calls, use your applications, take pictures, and so on. Oh, not camera, maybe take pictures and so forth, right? These are now your functions. In other words, these are the things that are publicly exposed to you by the smartphone, if we think of it as a class. So it's saying, look, I have a whole lot of other things inside me, which are private. In other words, as much as using me is concerned, just what about making your calls using applications, taking pictures, and so forth and so forth. These are then your functions. But for this to work, your phone needs certain things that are hidden inside, which is what's now under private. So your data members or your private members that are under private enable your class to do all these functions. So in defining a class, in most cases, you'll be given everything, like these are your member variables, these are the functions, this is what each function does. All you have to do is to define it, which means when defining a class, you have to understand, okay, what are my member variables? The items that are private within the class. So in other words, the class is hiding this to whoever is going to be using this class on stage number 3. Okay? Which means when we are defining the class, we have access to everything because we are the ones creating the class. So we've got access to everything. We're the ones who are putting the motherboard, we're creating the charging system, putting the GPS components, the battery, putting the camera equipment, everything that we need, we're the ones doing this. So at the stage of defining a class, we have access to everything because we are creating it. It's like we're creating a device. So at this point, we have full access because we are defining what it looks like. That's the definition. But when defining a class, whatever we put under private, we are saying that when whoever is going to use this class, they don't need to know about these things. These are internal to the class. They just need to worry about carrying on with their business. Okay? So this is going to become important when we then start talking about class usage at stage number 3. When we use it, when using a class, we have to be conscious and be mindful of the fact that there are certain things in this class that we cannot use at this stage or we cannot access at this stage because they are private. And that is where the confusion normally comes in because you are being conscious of, oh, these things are private, I shouldn't access them. But then at some point you need to access those things and do certain things. So you have to be very clear where you are. If you are here defining the class, you've got access to everything, you're the manufacturer, right? We can think of you that way. And this is what you do. You make your functions and you define your member variables, and that's it. And for the most part, your member variables are private. And if you don't specify whether it's private or public, everything is private by default. So be very conscious of that. If you don't specify that it's public, it'll be treated as private. But that's how we define a class, and then we put our semicolon at the end. Functions are governed by the functionality of your class. It depends on what your class is going to do. And for the most part, you'll be given, the names of the functions and what they do. Like in this case, we've got an input function, which I guess is going to be used to ask the user to provide the month and the day somewhere in there. This one is maybe being used to display the month and the day. This one will set the month to a certain value. This one will set the day to a certain value. So that is the basics of a class. And at this point, we are talking about defining a class. Now, from defining a class, the next thing you have to do is you have to implement every single function. Right? I'm going to preempt here when it comes to ADTs because that is how we always do things. When you define your class, this is defined in a separate file that we may call, in this case, maybe day of year.h. And that's your definition, which is also referred to sometimes as the interface for your class. Because whenever we define classes, we always define our classes in a separate file. So the class definition goes in a separate file. We'll talk about this later on when we talk about ADTs. But whenever you define a class, you define it in a separate file, which is referred to as the header file, or this is referred to then as the class the class interface. Then when it comes to the second stage, which is the implementation, this is normally done in a separate file, which is then referred to as the source file, right? So this we can refer to as the source file or the implementation file, right? And usually this would have a .cpp extension. And what you do in this file is you have to include your header file, which is where your declaration is. And once you include your header file, you then have to implement every single function that is in your class. But what happens is, let's say you've got 3, 4, 5 classes. Your compiler is going to combine all your source files into one file. So when implementing your functions, how does it know where the function belongs? Does it, like, which class it belongs to? Let's say we had 3 classes and then the compiler combines all your implementations into one file. How does it know where this function belongs? Maybe you've got another input function in another class that is somewhere. For that reason, we always have to specify where this function belongs by putting the name of the class behind the function, right? So you go class name dot input, which means you still write your functions exactly as they are here, but behind every function name, you put the name of the class, which is your scope resolution operator, saying this function is coming from the day of year class. This function is coming from the day of year class, which means when your compiler combines all your implementations into one massive file, it still knows where this function belongs, which is day of year. So you realize that whenever you implement your functions, you have to specify the name of the class behind every function name. Everything else remains exactly the same. And the logic that goes inside your function depends on what the function is doing. For instance, in this case, our input function is being used to get values of day and month from the user. Our output is being used to display the day and month with a space in between. Our set month is going to set the value of month to whatever has been provided. And our set day is going to set the value of day from whatever attribute or value we've been given. So the idea of implementing a class is simply implementing every single function that is in your class. And at this point, you have access to everything. All your functions within your class, whenever you're implementing them, they have access to everything under private because this is one object. So at this point, whenever you're implementing your functions, you're not really worried about, oh, is it private, is it not? Because it's within that class, all these functions can directly access all these member variables because they belong to one class, they belong to one object. It's one thing. It's that idea of our smartphone with all these gadgets. It means that, when you press some buttons here, they have direct access to this circuit inside because it's one object. All right. So at this point, you're not really worrying about, oh, is it private? Can I access it? We are going to discuss the way you need to start worrying about accessibility when implementing a function when we do inheritance. Okay. But for now, when just implementing a class, your functions do have access to everything in your class because it's all one thing. Now, once you have implemented your class, it means you now have a complete object that you can now start using. But whenever you're implementing a class, there are basic operations that I want you guys to be comfortable with, right? Because these are special functions that are always mentioned using like mutator functions and accessor functions. And the idea behind this is this. We have defined a class, right? Which shares month and day that are private, which is fine. But what are we going to do if we want to display the month and day when we get to stage number 3, which is using the class? When we get here, how are we going to display this day and month? Because maybe we want to do it. Because we do know that at this stage, everything private cannot be accessed. So because all your data members are private, we need to create functions that can allow us to get their values and to set their values. Because we cannot directly access their values or set or get their values at this level. When we start making a variable of type day of year, we cannot say day of year dot month or dot day because they are private, which means when we get to this level where we start using our classes, where we start making variables of type of our class, we cannot access everything under private. So what you do, the idea is that for every member variable that you want to expose, you have to provide 2 functions. One that allows it to set this value, one that allows you to get this value. Setting a value is also referred to as mutating or changing it, right? So whenever you see the word mutate under programming, we're talking about changing the state of an object or changing the value of a variable. And hence, a function that you're going to use for the purposes of changing it is then referred to as a mutator function because it mutates that variable. And a function that you use to retrieve the value of this variable is then referred to as an accessor function. In some languages, they just refer to them as get and set functions. But here they are very specific about using the word mutator and accessor. So there's nothing really special about these functions except the fact that you need to use them to get this value or set this value so that when someone is then using your class, they are able to get the value of month and get the value of day and set the value of month and set the value of day, depending on which ones you want them to be able to do that. So in most cases, the general convention is to use the word set something or get something for your function names. It's not a rule. It's just that it's easy to read your code. So if we want to set the value of month is an integer. So we need a function that can receive an integer for us so that it can go and set the value of this month, which is our mutator function. So here we've got a set month function which receives an integer value m, which means when implementing this function, it's going to set the value of month to whatever has been given to it. And it's a void function because it doesn't have to return anything. So your mutator functions are always void, and they receive the value that you want to set your data members to, which means if someone wants to set the value of the month, because it's private, they have to do it through this function. This function will receive the value and they'll go and set the value, right? A get function allows you to get the value of that member variable, which means in this case, if we want to get the value of month, we can use a get function. And here you see we've got a get month function and it returns whatever this is. Because we are simply getting the value, our function doesn't need any arguments. It's simply a get function. So we can say get month and it returns an integer. And inside the implementation of this function, you can simply return the month. That's all it does. The constant modifier that you see here, we're going to talk about it separately, but it simply means that this function does not change anything, as you can see. So whenever you see constant at the end of the function, it simply means this function does not modify or does not mutate any of these member variables, okay? It can mutate anything else, but it cannot change these member variables, which is what it does, because it simply retains a value. And the same goes for our day variable. We've got our set day function and our get day function. So those are your accessor and mutator functions. And in most cases, when they say implement a class or define a class, they normally want you to include these functions for at least a few member variables that you have. So you have to get used to the syntax of, okay, a mutator function will receive a value and it will go and set it and it returns nothing. It's a void function. An accessor function is going to return the value. So it takes no arguments and it returns whatever type of member variable it needs to return. And that's it. That's your mutator and your accessor functions. The other special type of functions also in a class that you should be aware of is the constructor, okay? When you define a class, right, and we have implemented a class, the third stage is going to be using your class, which means you can now make variables of type day of year, like in this case. So right now, we can make variables of type day of year, and this works exactly the same way you've done with other types of variables, like integers. When you go int x, int is a class, day of year is a class. You make a variable of type int called x, you make a variable of type day of year called d1, and you've got d2. These are referred to as instances, which is why sometimes we refer to this process as instantiating or making an object. These are called objects, instances, variables, whatever you want to call them, okay? So we can say we have an object of type int, or we have an object of type day of year. So now you realize that in this case, we have two objects or two variables of type day of year. Each one has its own data and functions. This has its own day and month. This one has its own day and month. But we cannot access the day and month of this object here because these are private. Now, so when you get to usage or when you start making objects, this is where you need to be mindful of the fact that I cannot say d1.day or d1.month because that is private. If I want the day and month, when using your class, you have to use your functions. And that is why we created these accessor functions. If I want to set the value of my day and the value of my month, I can now use my mutator functions. This allows me to go and set the day of D1 to 12 and the month of D1 to 2, which means in D1, the day is now 12, and in D1, the month is now 2. We can do the same for D2 and set the month to something else and the day to something else. So that is what it means. So whenever you get to that last stage of using your objects, that is where you need to be mindful of the fact that not everything is accessible, because what we've done is we've created our smartphone. Now we are using it. So at this point, we don't have access to all the circuit boards and all the components that are inside our smartphone. We just have to use whatever it exposes to us, which is the screen, the buttons, and everything, right? So that is the same idea behind the class. You create it, which means you put everything together, you provide the implementation, the functionality, and you package it. That's it, done. Then stage 3, let's use it, which means it's now behaving like a normal variable, or a normal type, like an integer or a string. A string is a class. Only that, so whenever you're using a string, you don't even know what variables are defined under string, right? These are predefined classes that are part of C++. And whenever you make a variable of type string, you don't know what member variables it has because they are hidden from you, which is the whole idea of putting stuff under private. Okay, so this is the last and final stage of using your class, which is now stage number 3. Now, I want to talk about a constructor, which is also another special function within your class. Okay, because whenever you make you instantiate your objects, and I'm talking about these 2 lines here. Whenever you make a variable of type day of year, D1, your compiler goes and executes your constructor. Because we are saying, what if I want to always default the day to 1 and the month to 1 every time you make a variable of type D1? Where do you do that? So a constructor is a special function that is executed or invoked by your compiler whenever it makes a new instance of your object. Okay, and a constructor is defined using the same name as your class. No compromising. So if we go back to our day of year class, this then becomes our constructor. And the purposes of a constructor is to initialize or to set the initial state of your member variables. You can say, well, I always want my month to start off at 1 and my day to start off at 1. Which means every time you make a variable of type day of year, you want your member variables to have default values. So every time you make a variable of type D1 here, your compiler here executes or invokes your constructor. You don't have to do anything, it does it automatically. All you have to do is to provide it. So a constructor is a function with the same name as your class. And remember, it carries no return type, not even void. Just the function name, and that's it. That's a constructor, which means when implementing our constructor, we still prefix it with the name of the class because we still need to know where it came from. So you have to put the name of your class, double colon, then the function name. Oh, sorry, this is not the right one we wanted here. I don't know how that slipped through my fingers. We just want this to open bracket here and to close bracket here. Don't worry about all of this. This is not for this part of the question. So we can, implement our constructor by then saying, well, day equals 1, month equals 1. So we are providing default values. And that is the purpose of your constructor, which means when you then make variables of type day of year, D1 and D2, let's say here you then say D1.set day to 12. It means in D1, your day is now 12, right? Which means initially, after executing this line, your month, your day here is now 1. Your month here is now 1. Same applies here. Your day is now 1 and your month is now 1. Then you execute these 2 lines which say, well, set the day to 12, which means for D1, day becomes 12, and for D1, your month becomes 2. But for D2, your day is 2-1 and your month is 2-1, which means if you then say D1 dot get day, you get 12 here. And if you say D1 dot get month, you get 2 here. But if you say D2 dot get day, you get 1. And if you say D2 dot get month, you also get 1. Because according to our implementation of the constructor, we said, let's always initialize the day to 1 and the month to 1. So constructors are very common when implementing a class, and they are used to provide the initial values for your objects, right? So this is usually referred to as the default constructor, the one that takes no arguments, default constructor. Just a constructor, open, close bracket, and it's used to set the initial or the default values for your member variables, right? And a constructor is invoked or executed when you make an instance or when you define variables of that class. That is where your compiler executes it. You don't have to call it. You don't have to do anything. Your compiler handles that. Now, the second type of constructor, which is still a constructor, is what's referred to as an overloaded constructor, because you can have more than one constructor, like you see in this case. We have our default constructor, which we've just talked about, and we have now what we refer to as the overloaded constructor. Because, function overloading is when you use the same name for a function but a different structure, okay? And this one is being used to allow the user to provide the values that they want to use for the initial state of these member variables. So in this case, we are saying, well, let's have another constructor which allows the user to set the day and month when making variables of type day of year. And we're going to take the day and set it as the day, and the M and set that as the month, which means we're now making variables of type day of year. You have two options. You can make a variable of type day of year and use the default constructor, and this is how it's done. And take note, no brackets. If you're making a variable and using the default constructor, you don't put brackets. This will use the default constructor. If you want to use the overloaded constructor, you just put brackets and you provide the arguments that are required by your overloaded constructor. So these are the two ways you can now start making variables of type day of year. If we don't have a default constructor, then it means you have to do it this way. In this case, we have both, which means we can do it this way or we can do it this way, which means in this case, our day becomes 23 and our month becomes 5. Like that. That is how you can then use constructors to provide the initial state of your member variables. And remember, this is when defining the class, when implementing it, that's how you implement your constructor. And when using it, that is how you then use your class. If it has constructors, you can make variables like this, or you can make variables like this. It's very important to understand these things, because sometimes they can give you a class and they ask to see if you can use it without showing you the implementation. So by just looking at a class definition, you must be able to know how to use it without looking at the implementation detail, because the implementation detail simply provide the logic. It doesn't show you how to use the class. The class definition is usually all you need for you to understand how to then use that class. Like in this case, I know I've got two constructors, so I can make my variables like this or like that. I've got all these functions which I can call here. I can call the set day function, which takes an integer. I can call the set month function to set the month. I can use the get day function to get the day and get the month, which means if we execute this code in day one or in D1, if we say get day, we get 12 here because we are setting it there. If we say get month, we get 2 because we are setting it there. In D2, if we say get day, we now get 23 because according to our constructor, that is what we put in. And if we say get month, we now get 5 because that is what we put in there. That is the idea behind constructors. So every time you define a class, these are the special functions that they mention, like here's your class, here are your member variables. Please put these mutator and accessor functions. And then they say also, please, do this constructor, do that constructor. And the idea behind these functions is very consistent. It's always exactly the same. Now, the last and final thing I want to talk about is abstract data types, which is the idea of allowing someone to use your class without them seeing the implementation of your class. Like, for example, whenever you use int, you've never seen the implementation of the int class. You just use it. So whenever you make a class as an abstract data type, it means you are, let me say this, you're abstracting the implementation from the definition. So the basic rules are you must provide the class implementation, or you must provide the class declaration or the class specification or the class interface in a separate file, which is referred to as the header file. And the implementation is then done in another file, which is called the source file. And your header file normally ends with a .h, and your source file normally ends with a .cpp. So in most cases, you would name this file as the name of the class, which means in our previous example, we would then have a day of, normally lowercase, year.h file, and we would have a day of year.cpp in our source file, which means in our implementation file, all we have to do is we say, please include our header file, and then we implement all the functions. And then in your header file, you simply include everything you need to use, like your IO stream, everything that you need to use. And then you just define your class. So that is how ADTs work. And again, you must always remember to make your member variables private. You must expose public functions, and any other functions that you don't really want to expose can also be made private. Right? So the idea of ADTs is very simple to observe, because it's about separating your header and your source file, making your member variables private, and making any other functions private that need to be private. So we're going to be looking at a couple of examples on classes, defining classes, implementing classes, and you're going to realize that for the most part, when it comes to implementing functions, it's not the idea of implementing a function that's difficult. Usually where people get stuck is the logic. It's the logic that goes into that function and fully understanding what your class is doing. But in terms of the concept, it's really simple. That is all we have to worry about when it comes to classes. So in the next upcoming video, we want to talk about overloading operators. What is overloading operators? What is the significance of doing it, and how is it done? Because it's a very huge piece of classes for this course, especially leading into file streams and using class objects. But at this point, I just wanted you to understand basically defining a class, implementing a class, and using it just from the basic principles of classes, because in most cases, people get lost in the detail. They see a question that talks about a class which looks complicated, and they think the whole idea of classes is difficult. No, it's not. So you need to be able to realize whether you are stuck with the basic idea of using classes, or you are just stuck with what needs to happen in this function, because you can do everything else that you understand. And if you don't know how to implement a function, maybe you can get that wrong, but you would actually get most of the marks if you just understand what needs to be done in the class definition, what needs to be done in the class implementation. For example, if I don't know how to implement a function, I would still write the function implementation and leave it blank inside. I may lose marks for not implementing it, but I'll get marks for getting everything right. So you must make sure that you fully understand how classes work and how to use them. Otherwise, let's move to the next video to talk about overloading operators. And then after that, we can look at a few past exam type questions on classes. Cheers. I'll see you there.